Okay, so this example on type 1 and type 2 errors is basically all we need to do is very, very similar to what we should expect in an exam. So the proportion of left-handed adults in a country is apparently 15%. I suggest that the proportion of left-handed mathematicians is greater than 15%. A random sample of 12 members from a university mathematics department is taken and is found to include 5 left-handed people. Okay, so a standard hypothesis kind of question there. They've mixed in a couple of things. Part A here I haven't really done, and I'm not really going to go through, but that is your step-by-step guide of a random sample there. From a sampling method, so you would create a numbered list of all of the members of the maths department, randomly generate a number on your calculator or using software, and select however many people you wanted, continue that process, blah 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 blahs. That step-by-step guide that you should have for how to conduct a simple random sample in context. Okay, B then, stating your hypotheses, test whether the suggestion is justified. So is the suggestion that the proportion of left-handed mathematicians is greater than 15%? So basically, conduct a hypothesis test, which I started off here. So hypotheses then are that no, mathematicians are just like the rest of the people, and then the alternative is that there are more than 15% of, there's a larger proportion of left-handed mathematicians. So what are we counting? So test statistic X is the number of left-handed mathematicians, and that would have a binomial distribution. I've selected 12 of them. Under H0 I'm expecting 15% of them, so I would expect 1.8, so about 2-ish of them to be left-handed on average, if H0 is true. Actually, in my sample, there were 5. Oh, that is more. But is that much more? Well, I don't know. How likely is that to happen in the normal population? How likely is that to happen in the kind of standard 15% of people, which is our binomial distribution here? What is the probability of me finding 5 or more out of 12 people that are left-handed if only 15% of people are meant to be left-handed? Well, that is 1 minus the probability of being less than or equal to 4. Again, on your calculators, the binomial CD, then 1 minus 0.9 something comes up as 0.0239, I believe. Oh, that's less than 0.05. Did they say 5% significance level? I missed that. Yeah, 5% significance level. That's less than 0.05. Therefore, strong evidence to reject H0. So strong evidence to suggest, what does H1 suggest? The proportion of left-handed mathematicians, sorry, write that out for you in an exam, don't be like me, is greater than 15%. Again, the strong evidence to suggest there's still, remember, a 2.39% chance, about a 2% chance that H0 is true if I find 5 or more people out of 12 are left-handed. So there's still a 2.39% chance there that they are just like the rest of us, those mathematicians. But that's quite unlikely. So there is evidence to suggest that H0 is not true, and we should probably favour H1. Okay. C. A significance test for an exact significance level of 5% can't be carried out. State the probability of making a type 1 error in this test. Remember, the probability of a type 1 error is your significance level. Now, what this question is telling us is that there isn't an exact value, there's not an exact X value here out of the 12 people that we can get that gives us 5% dead on as a probability, as a p-value. So basically find the first one that would lead to rejecting H0. So find your critical region. So the probability of your critical region is your significance level. Probability of your critical region is your significance level. So we already know that the probability of being greater than or equal to 5 leads to rejecting H0. I'm expecting 1.8. Okay, what if it wasn't so high then? What if it was only 4 of them out of 12? What does that come to? Again, that's 1 minus the probability of being less than or equal to 3, which is 0.0923. That comes out as. Which wouldn't be enough, that's greater than 0.05. So actually, in this case, we've just about 5 is the first value. Critical region is greater than or equal to 5. 5 is the first value. That gives a p-value of less than 5%. So that would be the first value that would start to make us reject H0. Is our critical region. So the probability of a type 1 error then, probability of a type 1 error, even though we wanted it to be 5%, we can actually be more specific now, is 2.39%. It's 0.0239, because this bad boy won't be enough to make us reject H0. 5% doesn't actually exist as a value, because the first value that leads us to rejecting H0 there is 0.0239. So that is actually the probability of a type 1 error. So for the probability of a type 1 error, find your critical region. So find the first value that leads to you rejecting H0, your critical value, and then find the probability of that critical region. That's the probability of the type 1 error. Then question D says, given that the proportion of left-handed mathematicians is actually 20%, here we go. So they give you the reality of a situation here. So actually 20%, that means that H1 is satisfied, it's greater than 15%. Now what if it is actually greater than 15%? What if it's specifically 20% of mathematicians are left-handed? Find the probability of making a type 2 error. So find the probability of sticking with H0 even though my proportion suits H1. So even though I should be going with H1, I should be rejecting H0. What's the probability of sticking with H0? So the first thing to do is to change my binomial distribution. So there were 12 mathematicians, and now I know for a fact there's actually 20% of them are left-handed. My critical region is greater than or equal to 5. My critical region is greater than or equal to 5. So if I'm in the critical region, I reject H0. For a type 2 error, I want to stick with H0 even though I know for a fact it's not right, it's false. So sticking with H0 then, well, that would be if X is 4 or below, outside of my critical region. What's the probability of being outside my critical region now with this new 0.2 instead of 0.15? And that then straight away from my... Oh, the baby's awake. I better go get him. Straight from my tables is about 92%. That's very, very, very high, but obviously this is a very small sample size. Usually, if you want to decrease the probability of a type 2 error, increasing the sample size is the way to go. I'm going to go get that baby.